Today we are going to learn about normal forms. The normal forms are nothing but a special kind of restrictions that are put on the right hand side of production rules, right? So we have a specific format that is to be followed by the production rules, so that they would be called as normal forms. Basically, there are two kind of normal forms. First is called as the Chomsky normal form, that is CNF, and the another one is the Gray-Batch normal form, that is GNF, right? So Chomsky normal form, it is basically used to generate strings, right, uh, of the language, the strings by using the Chomsky normal form. Strings can be generated easily, and it is basically used to prove that certain string belong to a language. And this normal form is used by the CYK algorithm, that is a Kokke Younger Asami algorithm, that generates a binary tree for parsing, right? And it uses the Chomsky normal form. The second normal form is the Gray-Batch normal form, that is used to prove the equivalence between context-free grammar and the push-down automata. Right? As we have seen that there was finite automata to represent a language that is regular language, which was generated by a regular grammar. Right? Similarly, there is a machine known as push-down automata that is used to represent the language which is generated by your context free grammar, that is a context free language. Okay, so if a particular grammar is in Gray-Batch normal form, then it is easy to obtain a push down automata from that particular grammar, right? So it is used, it is easy to prove that a context free grammar is equivalent to a particular push down automata by using Gray-Batch normal form, and it is also used for parsing also, right? So these are the two uses of these two different forms, that is the Chomsky normal form and Gray-Batch normal form. Now what kind of restrictions would be there, or how can you identify whether a given grammar is in CNF or in GNF? So we need to discuss about the rules or the restrictions that are on the production rules. So any context-free grammar can be represented either by a Chomsky normal form or a Gray-Batch normal form if the language is free from epsilon production, right? So if there is no epsilon generated by a particular language or a grammar, then you can represent that grammar either in CNF or in GNF, right? So every context free language without epsilon, it can be generated by a CFG with rules of the following form, and the form are CNF and GNF. So any grammar is said to be in CNF if all the production rules are restricted to have these two forms. That is, a single non-terminal will derive to two consecutive non-terminals, like A derives to BC. So here A is a non-terminal and BC are also non-terminal. So if all the production rules are of the form that is a single non-terminal derives to two consecutive non-terminals, this, if all the rules are of this format, then we say that it is in CNF. Otherwise, if not this, then the other form that a production rule can have to be in CNF is, that is, a single non-terminal derives to a single terminal. Right. So either the production rule should be of this particular form or of this form, wherein A is a non-terminal and small a is a terminal. So if all the production rules obey these two uh, syntax or these two rules, then we say that the given context-free grammar is in CNF, right? Now, otherwise it is simple context-free grammar, right? Then there is another normal form, that is a Gray-Batch normal form. Again, we have some restrictions on this, the right-hand side of production rules. So, in Gray-Batch normal form, the production rule should obey the following syntax or the following rules. That is, a single non-terminal on the left-hand side. Obviously, it is a context-free grammar, so there must be a single non-terminal on the left-hand side. That's why in the earlier I said that here itself I said that the RHS of production rules are restricted to have a specific format, because always in context-free grammar, the left-hand side have a single non-terminal. So a single non-terminal derives to a single terminal followed by series of non-terminal, right? So on the right hand side, if the product of the production rule, if there is a single terminal followed by series of non-terminals, right? Or there is a single terminal on the right hand side. If these rules are there, if all the rules follow this particular structure, then we say that the given context-free grammar is in GNF. See, what is the structure? A non-terminal on left-hand side. Now on the right-hand side, you can have a single terminal followed by series of non-terminals, or only a single terminal on the right-hand side. Right. So this can also be written as a non-terminal A derives to, these two rules can be merged like this: a terminal followed by a non-terminal ka closure. N means a non-terminal. Now closure means it can be epsilon also, right? So these two rules can be written like this: there can be any combination of non-terminals, but it should be followed by a terminal. So there can be zero or more non-terminals. Okay, is this clear? Hello, am I
Yes, sir.
audible? Yes, okay. Then, right, this is about normal form. So there are two types of normal form. First is the Chomsky normal form, where the production rule should have a structure that is a single non-terminal derives to two consecutive non-terminal, only two consecutive non-terminals, or a non-terminal derives to a single terminal. Whereas there is another normal form, that is Gray-Batch normal form, where the production rules are restricted to have a form that is a single non-terminal derives to a single terminal followed by n number of non-terminals, consecutive non-terminals, or a non-terminal derives to a single terminal, right? And we have already seen that CNF is basically used to answer whether a particular string is generated by the given grammar or not. And this is done by using the CYK algorithm, that is a Koche, Oke, Younger, and Kasami algorithm. This algorithm was named on the name of three scientists who developed that. These are the three name of three scientists on which the algorithm was named, right? And Gray-Batch normal form is used to prove the equivalence between a push-down automata and a context-free grammar, right? It is also used for parsing also, right? Then uh, suppose a given grammar is given, and you want to apply CYK to it, then you need to convert it to CNF. So it would be easier. And if a grammar is given and you are asked to convert it to a push down automata, then it would be easier to convert the given grammar or context free grammar to GNF first, and then convert it to push down automata, because it will be an easy process. Then suppose a context free grammar is given to you and it is not in CNF or GNF, then there must be some procedure to convert it to either CNF or to GNF, right? So for that purpose, what we'll do, we'll see how we can convert a context-free grammar to either CNF or GNF. The first, we'll see how can we convert it to CNF, and in the next class, we'll see how can we convert a context-free grammar to GNF. So the first step, as we already seen, that context-free grammar is said to be in CNF if the production rules are restricted to have the following form. The form that we have already discussed in the previous slide, that is a non-terminal, that is A derives to a non-terminal B and C, that is two consecutive non-terminals, or a non-terminal A derives to single small a, that is a terminal, right? So this kind of rules are there. Then we say that the grammar is in CNF, right? Then here we are required to convert the given grammar in CNF. So these are the rules. S derives to small a, capital S, small b, and S derives to small a, small b. The language which is represented or generated by the given grammar is A power n, B power n, such that n is greater than equals to 1. Now, is the given grammar in CNF? Yes or no? Is the given grammar in
No.
CNF? No. Why? Because it is not following the structure of CNF. There are more than there is a non more than one non terminal on the right hand side, right? So if such kind of grammar is given to you and you are asked to convert it to CNF, then there are two steps that is to be followed, and very simple. This is very simple to convert a given context free grammar to CNF. The first step will be to introduce a new non-terminal for all the terminals in the grammar, right? So here there are two terminal symbols like A and B. So you can introduce two non-terminal, new non-terminal for all these terminals, right? So here there are two terminals A and B. So we'll be introducing two new non-terminal for these terminals. So let us introduce capital A for small a and capital B for small b, right? Then what we would be doing, we would be replacing all the existence of small a and small b in the given production rule by capital A and capital B, and we'll add two new production for capital A and capital B that would derive to a terminal A and terminal B, that is small a and small b, like this. So after introducing this and replacing them in this production rule, the rule will become S derives to capital S, capital S, capital B, S derives to capital A, capital B. And now for this capital A and capital B, we would be adding two new rules. A derives to small a and B derives to small b. Right? Now, looking at this, we can see that this rule is obeying the structure of CNF. Am I correct? Right?
Yes, sir.
Single non-terminal, and on the right hand side, two consecutive non-terminals. So this is obeying this structure. Here, single non-terminal derives to single terminal. This is also obeying the uh, rules, and this one is also obeying the rules. So these three production rules are obeying the structure of CNF, and we can say that this part of the grammar is in CNF, but the complete grammar is not in CNF because this rule is not in CNF, right? So we need to convert this kind of rules also to CNF. So in the next step, what we'll do, we'll identify such kind of rules, right? So if there are a rule that is a non-terminal derives, as we have converted all the terminals to non-terminals, so such kind of rules will have on the right hand side. Either there will be a single terminal or there will be series of non-terminals, right? It is obvious because we have converted all the terminals to capital alphabets, that is non-terminals. So the rules will be of this kind. It is a non-terminal derives to series of non-terminals, that is B1, B2, and so on, BM, right? So the rules will be of this type. There can be any number of non-terminals on the right hand side. So if this kind of rules are there, then what we'll do, we'll keep the first non-terminal as it is and replace the remaining part of the string by a new non-terminal, right? Suppose this is n, so there would be any new non-terminal. Then again we'll be adding a rule for this n such that this n will derive to this starting part of it, that is b2, and the remaining will again be replaced by another non-terminal. Let us call it as m, right? In this way we'll go on until last two symbols are there, like this. We'll see like this. Suppose what will do, suppose this is the string, then we'll keep the first non-terminal as it is and replace the remaining substring by a new non-terminal. Like we'll write a rule, a derives to b1 will be as it is, and for the remaining part we would be adding a new non-terminal d1. Now this d1 should derive to this part b2 to bm, right? But again, if we write like this, d1 derives to b2 b3 dot 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 bm, so it would again not be in CNF. So what we'll do, we'll apply the same rule. Let we'll write D1 derives to the first non-terminal, and for the remaining non-terminal, we'll introduce a new non-terminal like this. So D1 will derives to B2, and then the remaining string will be replaced by a new non-terminal. So we'll go on doing this, like D2 will derive to B3 D3. Now we'll go on doing this until we are on, suppose there are M symbols in this production rule. So we'll do this up to M minus 2 times, right? So at the end, what we'll do, Dm minus 2 will derive to the last two. Suppose this is Bm, so the previous one will be Bm minus 1. So we'll write a rule, Dm minus 2 derives to Bm minus 1 followed by Bm. So here there would be end. Okay, so here what we'll do, we'll always keep the first symbol as it is and replace the remaining part of the string by a new non-terminal, and we'll go on doing this until we reach the end of the string, until there are last two symbols only that would be derived, right? So similarly, this kind of rule is to be applied over here on this rule, right? So what would we do here? S derives to ASB is a rule. So this is the first symbol. We'll keep it as it is, and the remaining two symbols would be replaced by a new non-terminal, right? Like this. So we introduce a new non-terminal AB. We can take any non-terminal. Here I have used B because here also I used D. You can use C, you can use X, you can use any non-terminal, any symbol, right? So here what I did, I kept A as it is and replaced SB by D. Now these are the last two symbols. That means I am in this situation, dm minus 2 like thing. Like this is suppose dm, so this will so this is bm, so this will be bm minus 1 and this will be bm minus 2. So I have reached this situation, bm minus 2. So this bm minus 2 will be d now, right? So d will derive to sb. This would be the rule, right? Now this single rule was there, and instead of this single rule I have added two rules now, right? And the remaining rules were already in cnf. Now you can see that this rule is in cnf, this rule is also in cnf, and this rule was already in cnf, right? So we'll add those rules as it is. Okay, now you can see that all these rules are in cnf. Is it okay? Is it okay? So for
Yes, sir.
converting a given grammar to CNF, you simply need to apply two steps. In the first step, you would be introducing a new non-terminal for all terminals symbols, and will replace them on the right hand side of the production rules, and you will add a new rule for them, right? In that you will observe how many rules are now in CNF, and for the remaining rules you would be applying step 2, wherein you would be identifying the rules with multiple non-terminals on the right hand side, and then again you would be introducing a new non-terminal, uh, and then you'll continue to do this until all the uh, production rules are converted to CNF form. Is it okay? Is there any difficulty in this? This is the easiest thing.
Sir, that last step not understood.
Which this one, step
Sir,
2,
that S derives to AB not understood.
this one. This was
Not
already
S
there.
derives to AB. Huh.
This one, na? We have just added it.
Acha, हाँ हाँ
These
हाँ
rules
yes
are
sir.
already there. The thing is that
Yes
instead
sir.
of adding
Yes
s
sir.
derives to
Understood.
ap at the
Understood.
start, I write it at the end.
Yes
Any
sir. Understood.
this is just copied from here to here. Actually, while typing, I left this, and that's why I added it to the end. You can add it over here also in between. There is no issue. The rules can be up down anywhere. Is there any other issue? See, if there is a question on CNF, this is the
No sir.
easiest. This is the easiest question to solve in TOC. You just need to introduce new symbols and replace them, right? So I hope you understood it well, and that's why I am giving you three questions to solve now, and in the next class we'll start with GNF. So while solving these three questions, you need to uh, go back to what I have told you today about normal forms, right? That is to be applied over there in one of the example, right? So just go through the definition of normal forms or CNF, GNF, and then solve the following questions. So you need to convert the following grammar to CNF. These are three questions. Uh, just solve them